Hello everyone, welcome to my channel. Today I am going to explain experiment number 5, statistical inference. In this experiment, we use Python to perform different statistical operations on the given data. We will calculate sample mean, population mean, confidence mean, correlation, covariance, headmark, and research state test. So let's start with question 1. Sample mean n equal to 500. The question 1 on the is calculate the sample mean price as an input pandas hybrid because we need it to work with the CSV dataset. Then I read the B5 underscore diamonds underscore SI, the CSV file stored in base. Next, I filter the data and consider only the diamond with good cut. After that, I select the price column. Using the sample of function, I randomly select 500 values. Random underscore series is to then we get the same sample every time. Use the main function to calculate the average price. Finally, put the register number, sample size, and sample mean. So the register program simply takes 500 good values and find the average. In question 2, the procedure is almost the same as question 1. First, we read the datasets and select the good cut category. Then we select the price column. The main difference is that when we select 1000 values instead of 500, after selecting the sample, we calculate the mean using the mean function. Finally, we display the result. The question helps us observe how the sample mean changes when we use a larger sample size. In question 3, we calculate the population mean. First, we read the data set and filter the good cut diamond. Then we select all the available price value. Unlike the previous question, we are not selecting only 500 or 1000 values. We use the complete selected data. Then we apply the mean of function. This gives us the average price of the population. So the main difference is sample mean uses selected data while the population mean uses the complete selected data. In question 4, we calculate the 95% confidence interval. First, we import pandas numpy. Then we read the dataset and select the good cut diamond. After that, we take a sample of 500 places. We calculate the sample mean and standard deviation. Then we calculate the Z value for a 95% confidence level, which is approximately 1.96. Using the Z value, standard deviation, and sample size, we calculate the margin of error. Then we calculate the lower limit and upper limit. Finally, we check whether the population mean lies inside the interval. So this code helps us estimate the population mean using the 95% confidence range. Question 5 is similar to question 4. We again take a sample of 500 places for good cut diamond. We calculate the mean and standard deviation, but this time we use 99% confidence level instead of 95. Therefore, the Z value becomes approximately 2.576. We then calculate the margin of error and find the lower and upper limit. When the confidence level increases from 95 to 99, the interval becomes wider. So, this question helps us understand the effect of changing the confidence level. In question 6, we calculate the confidence interval 25 times. First, we create two empty lists to store the lower and upper limit. Then we use for loop to repeat the process 25 times. In every trial, we select a different sample for 500 places. Then we calculate the mean standard deviation and 95% confidence level interval. We store the lower and upper value in the list. Finally, we use matplot to plot all 25 confidence interval. The graph helps us visually understand how the confidence interval changes for different samples. In the question 7, we find the relationship between weight and blood pressure. First, we create two lists containing the weight and blood pressure values. Then we import the Pearson function from SciPy using we calculate the Pearson correlation coefficient Pearson correlation tells us about the linear relationship between two variables, the values between -1 and +1. In our result, the correlation is approximately 0.6102, which shows a positive relationship. So this code is used to find the linear relationship between height and blood pressure. In question 8, we again use weight and blood pressure, but this time we use Pearson correlation. We import the Tierman's function from SciPy. Then we pass the two list to this function. Pearson correlation works using the ranks of a value. The result is approximately 0.7000. This shows a positive relationship between the two variables. So, in simple words, Pearson checks the linear relationship while Spearman checks the linear relationship based on ranks. In question 9, we have marks for maths, English and art. First, we create the data frame using pandas. Then we use the covariance function to calculate the covariance matrix. Covariance tells us how two variables change together. Next, we use the correlation function to calculate the correlation matrix. Finally, we use Seaborn headmap function to display the correlation values visually. The anode equal to true option displays the value inside the headmap. This makes it easier to understand the relationship between three subjects. Finally, in question 10, we perform a research test. The population mean is 1800, the population standard deviation is 100, the sample size is 50, and the sample mean is 1850. The critical reserve value is given as 2.33. First, we store all these values in variables, then we calculate the reserve value using the ZS value formula. The calculated reserve value is approximately 3.5355. Next, we compare 3.5355 with the critical value 2.33. Since 3.5355 is greater than 2.33, we reject the null hypothesis. Therefore, the given claim is supported. So, this code helps us use sample data to make a statistical decision about the claim. So this is the end of the experiment 5. In this experiment, we learned how to calculate sample mean, population mean, confidence interval, Pearson correlation, Spearman correlation, covariance, and ZS using Python. We also learned how to represent correlation using a head map and confidence interval using a graph. Overall, this experiment shows how Python and statistics can be used together to analyze data and make decisions. Thank you for watching this video.